Hey everyone, my name is Jessica, and today we are going to solve a limit problem using L'Hopital's rule and also some log properties to help us out. So first let's go over what L'Hopital's rule is again. Basically, the rule is a really helpful way. You're trying to take the limit of something that's in an indeterminate form that is either 0 over 0 or infinity over infinity. So let's just say you're taking the limit as n approaches c, which can be a finite number, positive infinity or negative infinity, of f of x over g of x, and you get one of these two forms. Then you can take the derivative of the numerator and the derivative of the denominator and take the limit again. And you can keep doing this until you get an actual limit. So let's look back at our problem. We're trying to find out what the limit is as n approaches 0 from the right side of 1 plus e to the power of 2x over 2 all to the power of 1 over x. Right away you see that you have your two functions. You have e to the 2x and 1 over x out here, but they're not really in that f of x over g of x form that we're looking for, so that might lead to some problems. Let's just go ahead and say that y of x equals 1 plus e to the power of 2x over 2 to the power of 1 over x. And if we just took the limit as it is right now, the limit as n approaches 0 from the right side of y of x, what does this equal? Well, if we put a 0 in here, e to the power of 0 is 1, and 1 plus 1 is 2, 2 over 2 is 1. We put a 0 in here, and we get 1 over 0. And this is indeterminate form, but it is not 0 over 0 or infinity over infinity. So we can't use L'Hopital's rule on it. But we can manipulate this around a little bit so that we can use it. Let's take the log of both sides just like this. And by doing this, we can bring this 1 over x out in front. So we can say ln of y of x equals 1 plus e to the power of 2x over 2 all over x. Whoops, ln. Just like that. And if we took the limit of this, let's see what happens. The limit as n approaches 0 from the right side of ln of y of x equals, if we put a 0 in right here, then we would get 1 plus 1 over 2 is 1, and ln of 1 is 0. And if we put a 0 in here, that would just be 0. And hey, that is a form that we can use, which means that we can use L'Hopital's rule and take the derivative of the top and the bottom to find what our limit is. So, let's take the derivative. The limit as n approaches 0 from the positive side of ln of y of x is going to equal, well first, before we do that, we should rewrite this a little bit so it's easier to take the derivative. So we could just say that, we can break this up to ln of 1 plus e to the power of 2x minus ln of 2. Now we have a constant, which will go away when we take the derivative, over x. So now let's take the limit. The limit as n approaches 0 positive of ln of y of x equals 1 over 1 plus e to the power of 2x. Remember, this goes to 0 and this goes to 1 down here, so neither of those two are going to carry through to here. And we also have to take the derivative of this inside part, so multiplied by 2e to the power of 2x. And we can rewrite this as the limit as n approaches 0 from the positive side of ln of y of x equals 2e to the 2x over 1 plus e to the power of 2x. And if we plug zeros in here, we get e to the power of 0 is 1, and e to the power of 0 is 1 down here as well. So this would be 2 over 2, and come out, so so that limit as n approaches 0 from the positive side of ln of y of x equals 1. And we're not done yet, because we're trying to find out what the limit is just of y of x. So to account for this ln, actually, let me slide this back up, that we took up here, to reverse this, we should raise our answer by e, which makes sense and is not that difficult. So the limit as n approaches 0 from the positive side of just y of x equals e to the power of 1, which means that e is our answer. And I hope that that made sense, and good luck.